Welcome to Brain Vision.
Okay, this one's kind of a goofy problem. The way we gotta start it is by just drawing a picture first and understanding what's going on. So we've got our box. There it is. Right, now we have a force that's 48 newtons, 61 degrees south of west. So the way we're gonna draw that force is we're gonna say, okay, here's west, that's east, and there's north and south. Okay, 68 degrees south of west means that the angle between west and this force is 60, or actually, sorry, I guess it's 61 degrees south of west. It's about right there. Okay, it means that that angle right there is 61 degrees. That's what 61 south of west means. 61 degrees. Okay, and this is a 48 Newton force. Okay, now we also have a displacement on here. So the displacement, we're told, is 12 meters, 22 degrees east of north. So east of north means to the right of the north direction. So that there is 22 meters. Sorry, 22 degrees. And this is 12 meters. That's the displacement of it in that direction. Cool. So now we go and we say, all right, work is the force times the displacement in the direction of the force. These two are not pointing the same direction. The simplest way to do this would be to pretend that since they're almost opposites, just kind of pretend they're in the same direction. But realistically, we would get and you know, if you want to be wrong but close to right, what you could do is just multiply 48 newtons times 12 meters, and that would give you something that's not right, but it's also not a terrible answer. But we do need to take into account that they're not even going opposite directions. They're going kind of there's a few degrees missing there. So basically, what we would need to do is we would need to project either the force into the direction of the displacement or the displacement into the direction of the force. So if we kind of trace back this displacement into the direction of the force, it kind of goes like that, right? You see if that was a straight line? And then we can say, okay, let's draw a right angle from here to here. That's a right angle. And we can define an angle theta over here. Theta. Okay. And then the distance, this component of the force from there to there, that component of the force is equal to 48 newtons times the cosine of theta. So that's 48 cos theta. If you kind of look at this problem a little bit and kind of think about how all the vectors would have to line up in order for there to be overlap in those arrows, you see that theta has to be equal to 7 degrees. And that's what it would take for the 48 and the 12 meters to be in the same line there. So then we can plug all our numbers in. We'll say work is 48 newtons times cosine of theta, which is cosine of 7, right? Times the displacement is 12 meters. And since the force is actually going in the opposite direction as the displacement, we've got a negative. Yeah, there it is.